Now would be a bad time for a bolt to break loose. Now would be a bad time for a roller to collapse. Now would be a very bad time for a wheel to crumple. And now would very definitely be a bad time for a brewery vat to fail.
Cheers. That's good. Well, as you can see, the brewery vat didn't fail. Nor for that matter did the bolt break loose, or the roller collapse, or the wheel crumple. But one thing's for certain. If any of those calamities had been about to take place, they would only have happened at the worst possible moment. Indeed, there's an engineering law that guarantees this. It's not a law that's taught in apprentice school or technical college, but one which every plant, service and maintenance engineer learns from the moment that he picks up his spanner. It's called SOD's law. Today I'd like you to meet the men who've learnt to respect, anticipate, and finally defeat that law. Practical engineers who've discovered a cure for SOD's law. This is British Sidak in Wigton, Cumbria. They run a non-stop process for making transparent wrapping film. 24 hours every day, 365 days every year. This company produces ton after ton of Rayophane and Rayop packaging film to protect our foods, our tobaccos, and our medicines. All vital ingredients, of course, for the survival of a television reporter. On this casting machine, the film starts as liquid viscose, fed into warm sulfuric acid. Then it ducks and dives its way through caustic soda, bleaching agents, and water washes, over and under, roller after roller. Eventually, these vital rollers will have to be renewed, and that's a problem British Sidak faced in 1980. Maurice Nicholson is an engineering manager responsible for maintenance, who started his career with British Sidak as an apprentice fitter 46 years ago. Maurice, I understand you had to make a lot of these rollers in a big hurry.
We did, Peter. As normal in industry, they were required yesterday. So the object of the exercise in manufacturing the roll is to fix the trunnion end into the tube. Now the traditional method we were using was to heat up the tube and then push in the trunnion end, and that shrunk the thing in. But to ensure that it didn't come out, we then had to weld round the edge. Unfortunately, because of the welding, it distorted the tube, and we then had to remachine the whole roll.
That must have been a very time-consuming business.
Very, very time-consuming and very unsatisfactory.
So what did you do next?
We then went completely opposite. We got liquid oxygen and then put the trunnion end into the liquid oxygen to shrink it, put it into the tube, but unfortunately, on a few occasions, we only got it halfway in. So obviously the tube was then discarded along with the trunnion end.
Well, obviously that wasn't very satisfactory. Where did you turn next?
We then turned to Loctite high-strength retainer. We didn't know much about high-strength retainer, so we then had to make two test pieces. One of the test pieces with 6 thou clearance and the other with 3 thou clearance. We took them to Carlisle Technical College, and the 6 thou piece pushed out at 27.5 tons pressure. So we were rather amazed that it had lasted so long. The 3 thou piece wouldn't push out at the maximum pressure of their press, 50 tons.
Is that the method you've been using ever since?
Yes, it's quicker, it's cheaper. We've used it now for 8 years, and we think it's passed the acid test.
But it isn't only rollers in acid, bleach and water that prove the Loctite method. Once Maurice Nicholson was convinced that it worked, he found all sorts of other uses for it. For instance, these aluminium core rollers have steel ends which are threaded and pinned. But the aluminium stretches. The pinholes become elongated and the steel ends loosen. and ends of lay-on rollers suffered the same damage. But now a Loctite retainer has replaced the mechanical method. But note, this is a high-strength retainer, and that's not the sort of engineering adhesive you'd want to use on parts you need to dismantle, which is why Mike Littleston from Gwynnops in Cardiff uses a mild-strength product.
Well, here's something that not even Loctite can fix. But of the 70 or so motors that we overhaul every week, none of them are as bad as this, thank goodness. One of the biggest problems we find is fretting and corrosion of the bearing housing and wear on the bearing journal. Our options are to bore and sleeve, metal spraying machine, or take up the slack with Loctite. And this is what we do in the majority of cases. We found that it stops any tendency for the bearing to spin in the housing, and it's quicker, it costs less, and is recommended by manufacturers. It's specified, for instance, to fit this pinion onto the shaft sleeve.
A retaining adhesive such as Bearing Fit isn't the only Loctite product used in the Gwinnett workshops. You'll also find multi-gasket, which replaces traditional gaskets to seal motor and gearbox flanges. If Mike tried to stock every gasket his men now replace, he'd need an extra store. And even then, not every gasket would be available when it was wanted. SOD's Law would see to that. Back in Wigton, British Sidak had a different problem with gaskets. These rollers are steam heated to shrink and set packaging film, but they often leaked, until Maurice Nicholson decided to seal them with multi-gasket. He threw away ordinary gaskets, and I asked him why.
You wouldn't ask that question, Peter, if you had the job of replacing it. This cylinder is heated to 120 degrees centigrade. The traditional method is to cut a joint by hand, to which we have to apply a paste each side to ensure it seals the cylinder end. Now, when I remove the joint, which becomes brittle and has to be replaced frequently, you can see how pitted the surface is. This has to be scraped away by hand, and in some instances the pittings are so deep that we have to put this up into a lathe and remachine that surface.
That obviously took a long time. Was there a quicker way?
That's right. That's when we turned to multi-gasket. So simple, I'm sure that you could put a continuous line round the holes on this end, Peter.
Well, let's give it a go. Well, this is a lot quicker than making a traditional gasket. Certainly something for the fitters of tomorrow's world. Are there any other examples of where you've departed from tradition?
Oh, aye, on our granulators. This granulator chops up waste film from the rail process so we can use it again. The cutting blades that do the chopping used to be held with self-locking nuts, but look what happened. The bolts came loose, and instead of chopping waste, the blades chopped nuts and bolts. If any metal gets into the process, it would be disastrous. So we make sure that the nuts stay on.
Guarding against disaster, anticipating the worst that SOD's Law could do, is nowhere more important than at Alton Towers Leisure Park. Here, the engineers and electricians who maintain Britain's biggest choice of rides and attractions aim to provide the public with complete protection. Each of the 55 rides must be absolutely safe. Before the park in the heart of England is open to its thousands of visitors, all rides are thoroughly examined. Each day starts with the cars being shunted into maintenance bays where every nut and bolt, bearing and shaft, and seat and strap will be checked. And the hidden parts the public never see or think about, the chassis, wheels, brakes and power links, will also be inspected daily. Then, after 3 days in service, individual cars are given an even more stringent examination. They're partially stripped to give access to drive motors and gearboxes. Finally, at the end of the season, every car receives a total strip down, followed by non-destructive testing. Then they're rebuilt, And the concern for absolute safety is again immediately evident. When reassembling gearboxes for the cars of the Black Hole and the Beast rides, for example, Warren France ensures that the drive wheel bolts remain tight.
I also lock the grub screws on this contact and brake lock, but here I use the strongest grade of Loctite thread lock, so I don't have to undo them again. They have to remain locked so the springs can't escape and cause the contact block to be released.
The dual-purpose blocks provide both power and emergency brakes for the Black Hole and the Beast cars. And going up, or coming down, the engineers of Alton Towers never take chances. They use a thread locking adhesive to secure the thread over its entire contact area. All the thread within the nut is locked when the adhesive cures. Note how every bit of space between the mating threads is filled, which means, of course, that the threads are also sealed. And this is an aspect of Loctite which is widely exploited at the giant plant of BP Chemicals Limited in Hull. The production of acetic acid, acetone and petroleum-based solvents at this 250-acre site never ever stops. It continues day after day, night after night. And to ensure that it continues, BP Chemicals employs 300 staff on planned and preventative maintenance.
Okay?
And whether they be experienced fitter or new apprentice, all are taught by engineering training officer Keith Wickham to seal pipe connections with a Loctite pipe sealant.
We've used pipe sealants on a variety of BSP fittings at BP now for many years. It's clean, easy to use and doesn't shred like PTFE tape. It also allows the craftsman to align elbows and gauges without over-tightening. Sealing the unions on a pneumatic differential pressure transmitter is a typical use of pipe sealant. There are hundreds of these operating all over the plant. They only work at 3 to 15 psi-G, so even a small leak will affect their operation. Pressure test rigs are another instance where we can't afford leaks. These connections must be leak-proof, or all the tests on the rigs will have false readings.
Not all connections are small or low pressure. This relief valve nozzle seal has a 5-inch diameter thread which is assisted by pipe sealant to withstand a downstream pressure of up to 3000 psi. The product used by BP Chemicals, however, would not be recommended for smaller parallel unions of hydraulic systems. For connections on, say, a forklift truck, hydraulic sealant is recommended. Like the other pipe sealant, this will also seal connections without excessive tightening. And, like the other sealant, connections can be undone using ordinary tools. And that's all you need to release nuts and bolts previously locked with Loctite, or bearings previously retained with Loctite. But some parts do need to be permanently bonded. Routine inspection revealed that fretting corrosion and scuffing had, after years of service, damaged the wheel hubs of airliners. British Airways then had the option of scrapping hubs costing £1,000 a pair or repairing them. The method used in the Heathrow workshops of the airline since 1972 is to first machine off the worn or corroded metal. After the resulting bare metal has been allochromed, a 300 series adhesive is applied. Using an adhesive eliminates the difficulties and expense of metal spraying aluminium alloy and resolves the problem of joining two completely different metals. A stainless steel shim is then bonded to the hub to provide the harder surface needed to counteract corrosion. And after a 1-hour cure, the hub is returned to the lathe. The shim is turned to restore the hub to its original dimensions, which is then ready for many more years of service. Joining different materials is always a problem, but adhesives make it practical, as the maintenance engineers of the Watney Truman packaging plant in Isleworth discovered some years ago. They needed to attach a rubber gasket to the stainless steel deadweight ring of a vacuum relief valve. The rubber has to be attached and sealed to the ring over the total interface to avoid the chance of bacteria forming. And of course, it can't be compressed or distorted by conventional fasteners. A special industrial superglue meets both of these requirements. And literally, within seconds, the completed ring is ready to protect a beer storage tank.
Superglues will bond all common engineering materials together almost instantly. Rubber will bond to rubber, for instance, in just 3 seconds. You want me to prove that to you? Okay. Put a tiny drop of superglue on the end, press together, and now start counting. 1, 2, 3. And there we have an instant O-ring. That's a technique used by BP Chemicals in Hull. A kit containing superglue and rubber cord provide the maintenance fitters with their own personal store of O-rings. The same is true in Gwyned's. The fitters in Cardiff no longer need to make the long trek to the store only to find that the store is shut or that they've run out of stock. They can apply their own instant, independent remedy. Like all the maintenance engineers you've seen today, they haven't waited for SOD's law to be proven right. They have anticipated the worst and applied their own cure for SOD's law from the Loctite frontline range of engineering adhesives and sealants.